Good day, everyone. Welcome. And for today, we're going to discuss and review about lines and planes in R3. So, recall first ng concepts. A unique line in R3 is determined by specifying a point on the line and a non-zero vector v, ABC, that is parallel to the line. Consider a line L that passes through the point P0 given by x0, y0, z0, and extends to an arbitrary point P given by xyz. We establish that this vector that extends from P0 to P is parallel to the vector V. In other words, for some real number T, we have that this vector from P0 to P is equal to T times the vector V. Or since the vector from P0 to P is given by x minus x naught, y minus y naught, and z equals z naught, we have that this vector is equal to t times the vector ABC. This is equivalent to saying that AT is equal to x minus x naught, BT is equal to y minus y naught, and CT is equal to z minus z naught. Therefore, we have the parametric equations of the line L to be given by x equals x naught plus AT, y equals y naught plus BT, and z equals z naught plus CT. The vector v given by ABC, or any non-zero vector parallel to v, is the direction vector of the line L. Now, when we solve for t, we form itong symmetric equations of the line. Kasi from here, from the parametric equations of the line, notice that we can isolate t from each coordinate. So we're going to have x minus x naught over a equals y minus y naught over b equals z minus z naught over c. Now, if exactly one of a, b, or c is 0, say, halimbawa c yung 0, we rewrite it into x minus x naught over a equals y minus y naught over b, and then yung isa isa-set natin as z equals z naught. Now, given two lines, L1 and L2, these lines may be first intersecting. In this case, a solution exists from the system of parametric equations of the two lines. This solution is the point of intersection. Two intersecting lines are perpendicular if their direction vectors are perpendicular. That is, the dot product of the direction vector v sub 1 and the direction vector v sub 2 is equal to 0. Now, the two lines can also be non-intersecting. If such solution exists, it can be further categorized into first parallel. The direction vector of one line is a scalar multiple of the other direction vector. That is, L sub 1 is parallel to L sub 2 if and only if their corresponding direction vectors are parallel. Now, it can also be skew, where the two lines are both non-intersecting and non-parallel. Now, a unique plane pi in R3 is determined by a point P0 given by x0, y0, z0 on the plane and the vector n given by ABC that is perpendicular to the plane. An arbitrary point P, x, y, z on pi follows this relationship. That is, the vector n is perpendicular to the vector that extends from P0 to P. In other words, they are orthogonal, or equivalently, the dot product of the vector n and the vector that extends from P0 to P is equal to 0. That is to say that the vector ABC, the dot product of the vector ABC and the vector given by x minus x naught, y minus y naught, z minus z naught is equal to 0. This is also saying that a times quantity x minus x naught plus b times quantity y minus y naught plus c times quantity z minus z naught is equal to 0. And therefore, we have the point normal form of the equation of the plane given by this. The vector n is called the normal vector to the plane. Any non-zero vector parallel to n, the vector n is also a normal vector to the plane. Equivalently, if we distribute the point normal form of the equation and we set d to be the sum of the constants here, in this case, negative a x naught, negative b y naught, and negative c z naught, we can get the general form of the equation of the plane. That is given by ax plus by plus cz plus d equals 0. Now, a unique plane is determined by any of the following. First, 3 distinct non-collinear points. Second, a line and a point not on the line. Third, 2 distinct intersecting lines. And lastly, 2 distinct parallel lines. Now, for planes, say pi 1 and pi sub 1 and pi sub 2, they can be first parallel if their normal vectors are parallel. That is saying that the normal vector n sub 1 is parallel to the normal vector n sub 2. They are perpendicular if the normal vector n sub 1 is perpendicular to normal vector n sub 2. That is also equivalent to saying that the dot product of their normal vectors is equal to 0. If neither, that is hindi parallel yung dalawang plane at hindi sila perpendicular, then the planes may be intersecting. Two perpendicular planes intersect at a line. That line has a direction vector equal to the cross product of the normal vectors of the planes. In the same way, when a plane and a line intersect, it intersects at a point. Just plug in the values of x, y, z from the parametric equation of the line to the equation of the plane to solve for t. Plug t in the equation of the line to find the point of intersection. We now go on with the problems dealing with concepts involving lines and planes in R3. So for the first problem, we are given with two lines. So consider the lines L sub 1 and L sub 2, whose symmetric equations are given by this. So for line 1, L sub 1, x minus 1 over 2 equals y plus 3 halves equals z plus 1 over 2. And for L sub 2, we have x minus 4 over negative 1 equals y minus 3 over negative 2 equals z plus 4 over 2. So first, we are tasked to find the parametric equations for L sub 1 and L sub 2. Second, we are to determine if the two lines are intersecting or non-intersecting. If they're intersecting, we are to find its point of intersection. Now, for the first task, for finding the parametric equations for L sub 1 and L sub 2, we note that in a symmetric equation, the values are equal to some variable. So for each x, y, z component, we express it in terms of that variable to find the parametric equations. So from earlier, we note that itong equality na to, this is technically equal to the parameter t. Ano? So yun ang yung gagawin natin dyan. We're going to set each component to t. And so we have this, x minus 1 over 2 equals t, y plus 3 halves equals t, and z plus 1 over 2 equals t. And upon solving for t, solving for x, y, and z pala, ayan, we're going to have these parametric equations for L sub 1. X equals 2t plus 1, y equals t minus 3 halves, and z equals 2t minus 1. Now for L sub 2, we're going to do the same thing. But for this one, we're going to set these to S kasi nagamit na natin yung t. So to avoid ambiguity, ayan. So we're going to set these to x and we're going to end up with x minus 4 over negative 1 equals s, y minus 3 over negative 2 equals s, and z plus 4 over 2 equals s. And then upon doing the appropriate operations, we're going to end up with these parametric equations for L sub 2. X equals 4 minus S, Y equals 3 minus 2S, and Z equals 2S minus 4. So for the next one, we are tasked to determine if the two lines are intersecting or non-intersecting. And if they're intersecting, we are to find its point of intersection. So, note lang natin, no, na yung direction vectors of the direction vectors v sub 1 and v sub 2 of the lines L sub 1 and L sub 2 respectively are implied by the coefficients of S and T in the parametric equations that we derived earlier. So, balik tayo. So, for L sub 1, ang kanyang direction vector is given by 2, 1, 2 mula sa mga coefficients ng T dito. And for L sub 2, it's negative 1, negative 2, 2. Okay? So, ayan. So, we're going to check if they are perpendicular, and that is by getting their dot product. So, upon obtaining the dot product of the direction vectors, 2, 1, 2, and negative 1, negative 2, 2, we're going to get 2 times negative 1 plus 1 times negative 2 plus 2 times 2. So we're going to have negative 2 plus negative 2 plus 4, which is equal to 0. So dahil ang dot product nito ay equal to 0, this implies that the direction vectors are perpendicular. Therefore, we conclude that the lines are perpendicular and are also intersecting. So dahil intersecting siya, we are going to find the point of intersection of the two lines. We form the system of equations below. So saan to galing? Notice na at point of intersection, ang kanilang corresponding coordinates ay equal. That is to say that 2t plus 1 is equal to 4 minus s, t minus 3 half is equal to 3 minus 2s, and 2t minus 1 equals 2s minus 4. Ayan. Diyan siya galing. And then, we may use the first two equations since there are only two unknowns. And then we're going to proceed by substitution. So from equation number 2, we can subtract, add both sides by 3 halves para ma-isolate si t. And then we're going to have t equals 3 plus 3 halves minus 2s. And then, itong t na to, we can substitute this dun sa first equation. So we're going to have 2 times, ito, pag pinag-add to, 9 over 2. So dyan siya galing. So 2 times 9 over 2 minus 2s plus 1 equals 4 minus s. And upon simplifying, we're going to have that. And then, we're going to have s equals 2. So we're going to plug in s equals 2 in the parametric equation of L sub 2 to find the point of intersection P. So ito ang kanyang parametric equation ng L sub 2, and upon plugging in s equals 2, so we're going to have this, and upon simplifying, we have the point of intersection 2, negative 1, 0. So next problem, we are going to find the general form of the equation of the plane that contains the two parallel lines with their corresponding parametric equations provided below. So for the first line, capital L sub 1, we have the parametric equations x equals 2 minus t, y equals 2t, and z equals 1 plus t. For the second line, capital L sub 2, we have the parametric equations x equals 1 plus 2s, y equals 3 minus 4s, and z equals 5 minus 2s. So let pi be the plane that is described above. We cannot directly get the cross product of the direction vectors to define the normal vector kasi nga parallel sila, and upon obtaining their cross product, we're just going to get the zero vector. So, ang gagawin natin is we select 3 points first on the lines. So, 2 of which on line 1 and 1 is on line L sub 2. So, for the first first point, point A, we're going to set t equals 0 on line 1. So, we're going to get the point 201. For the second point, we're going to set t equals 1 on line 1 pa rin, and we're going to obtain the point 122. For the third point, we're going to set s equals 0 on line 2, and we're going to get 135. So we then create the vectors AB and the vector AC and use it to determine the normal vector. So the vector AB is the vector that spans from point A to point B, and the vector AC is the vector that spans from point A to point C. So vector AB is -1, 2, 1, and the vector AC is -1, 3, 4. So their cross product is gonna be the normal vector. And if naalala ninyo, the cross product is going to be like this. So for the first coordinate, that's equal to the product of this minus the product of this. So 2 times 4 minus 1 times 3. So for the second coordinate, y coordinate, that's going to be the negative of the product of this minus this one. So that's going to be negative of -1 times 4 minus -1 times 1, or if apply na natin yung negative sa labas, that's going to be -1 times 1 minus 4 times -1. And then for the z coordinate, that's gonna be the product of this minus the product of this. So that's -1 times 3 minus -1 times 2. And then, upon simplifying, we're going to have the normal vector to be 5, 3, and -1. So, taking the normal vector n and the point A, which is 2, 0, 1, to create the equation for the plane pi, we have 5 times quantity x minus 2 plus 3 times quantity y minus 0 plus -1 quantity z minus 1 equals 0. And upon simplifying, we're going to get the general equation of the plane to be 5x plus 3y minus z minus 9 equals 0. Now for the third problem, we consider the planes pi sub 1 given by this equation, x minus 2y plus 4z minus 4 equals 0, and pi sub 2 given by 2x plus y minus 4z plus 4 equals 0. We are to determine the symmetric equation of the line of intersection L, and also determine the angle between the planes pi sub 1 and pi sub 2. So for determining the symmetric equation of the line of intersection, we rewrite the equations of pi sub 1 and pi sub 2 in terms of z. Ayan. So we're going to isolate z here sa bawat equation ng mga planes. Ayan. And at the line of intersection, we have that pi sub 1 equals pi sub 2. That is to say na equal ang kanilang mga z coordinates. So we have the following. Negative x over 4 plus y over 2 plus 1 equals x over 2 plus y over 4 plus 1. And then upon doing the appropriate operations, we're going to end up with y over 4 equals 3x over 4. And that's gonna be y equals 3x. So, yan ang ating Yan ang Cartesian equation na ating line of intersection. So, letting x equals t so that y equals 3t, we're going to have z equals x over 2 plus y over 4 plus 1. And that's going to be t over 2 plus 3t over 4 plus 1. And that's going to be 5t over 4 plus 1. So, we're going to have the parametric equations x equals t, y equals 3t, and z equals 5t over 4 plus 1. And then, isolating t from each coordinate sa mga equations na to, we're going to get the symmetric equation of L, which is given by x equals y over 3 equals z minus 1 over 5 over 4. Now, to determine the angle between the planes pi sub 1 and pi sub 2, we note that the direction vectors of the two planes are 1, negative 2, 4, and 2, 1, negative 4. We use the dot product of the normal vectors to find the angle theta between the two planes. Now, we note that the dot product of the two vectors is equal to the product of their norms times the cosine of the angle between them. So to isolate the cos theta here, we just divide both sides by norm of n sub 1 times the norm of n sub 2. And so we end up having this equation. Ayan. Then upon plugging in the given values, now for the product of n sub 1 and n sub 2, we have 1 times 2 plus negative 2 times 1 plus 4 times negative 4 all over norm of n sub 1, that's square root of 1 squared plus quantity of negative 2 squared plus 4 squared times square root of 2 squared plus 1 squared plus quantity of negative 4 squared. And then upon simplifying, we're going to end up with negative 16 over 21. So we have cos theta equal to negative 16 over 21. We can simply let theta to be our cosine of negative 16 over 21, since negative 16 over 21 is in the closed interval negative 1 to 1, and our cosine of x is in closed interval 0 to pi for any x in the closed interval negative 1 to 1. So yun lang naman. If you have questions sa discussions dito or sa mga exercises that we had, don't hesitate to comment them down below, or tanong nyo sila sa respective instructors ninyo. Yun lang, and thank you.